Oh, wait, it's being recorded. Oh, yeah.
I think
I'm on
we're
this
ready
side.
now. Yep.
I thought I was gonna share screens, but it's all good. All good.
All good.
Because
All right.
I'll share screens later.
Okie dokie. Good morning, everybody. Thank you very much for coming to today's first official, well, unofficial bootcamp session hosted by IT at Monash Discord server. I will be your host today. My name is Jamie. I am the server owner of the IT at Monash Discord server, and with me today is my fellow
I'm Jordan.
co-host,
I'm also
Jordan.
admin, and I'm a better admin than him. That's all you gotta know.
You think so, but I'm still the better one. Anyway,
right one.
Welcome to today's session. So today we will be giving you just a basic introduction into the world of programming, and by that we'll be introducing you to Java. So how today's session will run, we'll essentially cover a few things. So basically, what is Java? What is the programming language? Its use in the industry, the software setup. Hopefully some of you have received the email from us, from itmarchdiscord@gmail.com. That should basically tell you what to set up. If not, we'll go through how to set up in a couple of minutes. We will also go through Java statements and variables, the basic stuff, and we'll also go through a little bit more complex stuff like conditional statements, as well as some loops and repetition, and times 99, and so on.
So okay, so this this presentation shows what the first 2 weeks of what Java was. Well, the next 6 slides will show what the first 2 weeks of Java was like. This whole presentation is essentially a summary of everything that happens within 1051, which is introductory to Java. The first 2 weeks show like why Java is so good, why it's better than C++, unintended behavior, and memory leaks. It doesn't have that sort of shit. Well, it does, but like it's done. And it's better than Python because it's not a snake. Next slide.
Now, as many of you know, Java is used for Minecraft, and this meme says it all. It's constantly updated, best redstone features, and arguably I would say it's better than the Bedrock edition. Correct?
No.
But there are also some other uses for Java, which we'll soon see. Also, I just want to quickly mention this in case anyone asks me. You might have heard of JavaScript, but the reality is Java is not the same as JavaScript. Now, this might sound surprising to you because there's some similar functionality if you've ever ventured into both of those areas before, but they are actually both different languages. And make sure you understand the differences and make sure you know that they're both completely different.
They mentioned that a lot. It's annoying as fuck.
Yeah. But let's get into what is Java really. And to put it simply, it's just a programming language, and one of the very popular ones like Python and C++ that we mentioned previously. Now, as I said, it's used in many different fields, obviously for Minecraft, but it's also used for web development and for application development for Android. It has a big focus on object orientation. So what do I mean by object orientation? Well, I basically, let's say you have a car, right? And car has some attributes, for example, the fuel gas, the amount of fuel it has, steering wheels, it can reverse, and so on. So there's many attributes that a car has. And object orientation kind of focuses on that a bit with objects itself, classes, methods, and variables, which we'll go over later on in the session. As well as this, it is used and taught in many units at Monash, such as Fit 1051, which I assume some of you will probably be doing this semester, as well as other second year and third year units, such as 2081, which is mobile application development. So Java is a fun unit overall. But before we get started, and I assume some of you might have done this already, which if you have, that's brilliant. We're going to just quickly go over this. How many of you have not downloaded this? Just want to ask.
Oh, anyway, I can show it. Like, I can show how to do it and all this stuff. So good?
Just let me know in the chat.
Come on. Yeah, that's it.
Download
Download right now. Okay.
Okay, yeah. You got it? Awesome. Do you guys need any explanation, or does this slide kind of make sense? Just let us know.
By the way, we have access to Ultimate Edition. All you got to do is like look up the educational license, do what that forms. You get an email, click that, but it takes longer to download and all that stuff because it has more stuff. They're gonna tell you that you should download Community Edition. Sorry, I'll just put that on there. They're gonna tell you to download Community Edition. It has all of what you need. Ultimate Edition just look nice. Just feels nicer, honestly. That's essentially it. Yeah, there's not much of a difference. Yeah.
Okay, so someone's just given me a message in chat asking me about the SDK thing. So if you want to quickly go over that.
I have no clue what that is, honestly. I just like beep beep beep.
So
Oh,
if
Java.
you open IntelliJ and you click a new project on the home screen, you have to like download a JDK. When you click on new project right on the home screen, when you first start up IntelliJ, right? You download the JDK where you basically click on the SDK project on SDK project. It should be version 15.
Yeah, that's right.
Yeah,
that's the folder that does all the Java thingy.
Oh, for Mac, yeah, there should be a guide as well. There wasn't that option in the scroll down menu. I think if you've got a version, then that should, yeah, there should be a guide for Mac as well.
Yeah, Jack's smart.
So I'll give everyone a couple of minutes. Just for people to kind of like go through stuff. Does anyone have any questions other than like the stuff we've gone through, or the download stuff?
That was going too fast.
Can we use VS Code in this unit? Do you know? Is there like a a rule on what you can and can't use?
So for this year, for 1051, we generally tend to use IntelliJ for everything pretty much. And we use that, you know, because it's got some good features on like debugging and stuff, like kind of how PyCharm is really good for that.
Yeah, you need IntelliJ project files.
I don't think it's best recommended you get Visual Studio Code or Visual Studio, given that the tutors and the lecturers kind of go through a lot of the stuff in IntelliJ, and it's probably best just stick with that.
Yeah, cool, within the first 2 weeks they start talking about like how IntelliJ is what they use nowadays in actual coding, and it's better than the other ones, which is, I mean, it's quite stupid. They're just trying to convince you, hey, listen to us because we know what we're teaching. But like, yeah, honestly, when personal use whatever you want. Just using this for this lecture. It's not this lecture, for this unit.
Question in chat, is this the only software needed for 1051? Yeah, there's not much you actually need to download. So you obviously, this stuff that we have on screen, that you definitely need to download. Apart from that, not really. The good thing about this unit is that you don't really have to actually buy the textbook if there is any for this year. There is an online kind of textbook with a free online one that they give you, and that's pretty much the only thing you really need to read for this unit. So make sure when you every week you read the online stuff, because that will be very useful not only for the tutorials that you do in the labs, but also for the weekly quizzes that 1051 usually does. They did some quizzes last year. I'm not sure if they're doing the same this year, but there should be an online textbook, and we highly encourage, if they've given it to you, you should probably read it.
Yeah, but don't buy it because no one, like, I barely used it. A lot of people barely used it. It's just useful to read like 1 or 2 lines from every once in a while, but it's highly encouraged.
We highly encourage you to just read through.
Yeah, essentially it.
All right, is everyone all good?
I hope. If there isn't, DM me, because like it's really embarrassing to be like, oh, I'm not done. So
I think, what time is it now?
I've got no DMs. So
it's all good. I think we'll go. I think now that we're here, I think we'll go and get
on
the next bit.
Just wait. Someone has very, very slow Wi-Fi. So let's wait an extra minute. Fuck it. We got tons of time. I mean, you said 2 hours.
Yeah.
I'd be surprised if it lasts 1/2, honestly.
We're also going to go into breakout rooms because we've got some exercises for you all.
True. Ah, wait, should I show him how to actually make a new project as well?
Yeah.
Really simple. Okay, it's on my screen.
Why don't you do that? Yeah.
Don't worry. Okay, so first thing you're gonna do is go into plugins, look at dark theme. It just makes it look sexy and it's so fucking cool. Like legit, I'm loving this. It looks amazing. This is a personal thing. You can choose other themes, but like the super dark theme is amazing. Go to new project. Click next, and insert a name. I'm just gonna do lecture, not lecture. Yeah, lecture. Why not? That's our project name. Done. Okay, you have a thing called SRC. That stands for source. Am I going too fast? I hope I'm not going too fast. Oh, we're meant to. Yeah, we're both sharing. Yeah, all good. Got me. Mixed up. Okay, you have SRC file.
Watch mine. Just watch mine.
Oh, but I'm sharing screens. I'm showing how to do this. Anyway,
Let me stop sharing.
SRC file is the source file. That's where all your Java can now see my. Wait, you couldn't see my screen before. That sucks. Anyway.
Okay, yeah, just start.
I'll start again. Okay, close project. New project. Next. Test. Insert the name. That was the name. The name was test. You have a file right here. It's called the source file, SRC. In here, you can create a Java class, which we'll explain later on, like the very end. But just know that Java classes are stuff you code in because it's object oriented. You can name it. Let's call it code. Always, when describing a class, capital letter first word. First word is capitalized. Every word is capitalized. Every word is capitalized. It's different for methods. It's different for other things. Just know that for every class, each word is capitalized. Code. Done. And then here, you can write your code later on. There's also sometimes a thing called a code driver. So a driver, which is just the name of that code, the class's name, and then just give it the word drive at the end, which, so you have your code, which does this sort of thing. And you have the driver, which gives it a different input sometimes. It's really confusing at the very start, but just know that people do it so it's easier to be read later on by other coders and by you if you forget how to code. What this project was. Just know you'll need 2 things for everything. 1 giving different inputs, 1 actually being the code.
Yep.
Anyway, this is the source file. This is the stuff that you read. When you run it, eventually they'll come with the compiler files, of which the computer reads because the computer can't read your stuff purely. It needs to be converted into computer text so it can understand.
Yep.
Okay.
All right. All right.
How do I get the SRC part up? Oh,
I'll share my screen now.
I got a DM.
Yeah?
How did you get the SRC part up? There's this button. Oh shit, fuck. There's this button right here, and it comes up SRC.
Yep.
Is that all good? Person that I won't name. Am I a bit confused? Yours doesn't have that. Oh no, what just happened? Close. Hopefully you're in my breakout room if that happens. Just new project. Oh, I don't know why that doesn't happen. I'll help you later on. Is that fine? Anyway, we'll work on it later in the breakout rooms.
The next bit is all just about theory anyway. So wait, I will share my screen now. So maybe turn yours off.
Stop share. Sweet.
All right, I'll share mine. All right. Can you all see?
Yes, you started sharing.
Okay, yeah, awesome. Okay, well, so now that we've gone into a little bit of this, now we've started a new project. Now we can now start with the coding. And what better way to do that than starting off with the basics? And the thinking question with the first topic is, how do we display something in Java? How do we display statements? How do we display mathematical equations? Well, the good news is it is actually relatively straightforward. So let's say I wanted to output some text like hello world. I could have gone with some other text, but this is kind of an intro to that. Anyway, what do I need? So I want to output some text like hello world. What do I need to write so I can display that bit of text? Well, we got some syntax here. We use system.out.println hello world. In other words, insert the text you want in here. And that's pretty much all you need to write any kind of output in Java. Now, the kind of I went blank there. Displaying something in programming language is relatively straightforward. In fact, it's also simple for Python or for C++ as well. And the good news is you can display the result of other things other than text, such as variables, or mathematical operations such as addition, subtraction. And we'll go into more of these a little bit later. But before we go through an example, I need to point out something very, very important. Now, as you might have noticed, there is a semicolon at the end of this statement. And why is that? Well, at the end of every single instruction, you must put a semicolon at the end. Now, why is that? Because one, it shows you where an instruction ends and where the next instruction begins. Kind of like at the end of a sentence, you have a full stop at the end of every single sentence. Well, in this case, it's a similar story in Java, but instead we're just using semicolons for the end of every statement. And here's an interesting part. Because of that, we can actually have multiple instructions, even in one line, which you'll see in a minute. Now, let's go through an example. Now, for this, yeah, the quote marks are very important. Yes, for text, the quote marks are extremely important when you're writing text down, for string variables, as well as for just writing text down into the output. Now, let's go for an example. Now, for this, I would suggest doing this with me, going on IntelliJ and trying it out for yourself. So I'm going to do a live coding example. So let's do statements. So I've got this here. Let's say I want to display the results of my name is Jamie. Okay, a little bit of a different text to the last time. How do we do that? Well, remember, system.out.println is the text, the things we need, the words we need to display that kind of output. And remember the brackets as well. And then we have that bit of text here. Now, let's say I want to display something a little bit different. How about a mathematical operation, like 15 times 9? Well, again, it's a similar story, but instead we don't have text because we're doing a mathematical operation. We're actually calculating something. So we don't need text. It's not a string. So for this, again, we do the same thing. We display using system.out.println.
Java is case sensitive. Yes, it is. Sorry, I was just answering a question.
Yes. Okay. Yeah. So from that question, yes, the Java stuff is actually case sensitive. So for example, if I put S here, this should actually be an error. So you can see here, cannot resolve symbol system. So for this, it is case sensitive. So be careful with that. Now, finally, and we'll go through variables a little bit after this. How do I display the results of a variable? Because we can do that here. So let's say I have a Boolean variable where the result is true. Well, since I've got the reference as result, I can just reference it when I do system.out.println of result. And that's it. So let's see. If I go to the driver and let's see what it does. So let's say I've got statement. Okay.
That's just that's just some code.
Yeah.
To make a class.
Don't worry about this bit yet.
Advanced stuff.
That's kind of a bit advanced stuff, but I just wanted to show you what the results would be. So let's see, it just takes a little bit of time for it to start up.
So they are.
So let me bring this up. So going back to here, so it's printed out, my name is Jamie as expected. We found that 15 times 9 is 135, which is good. I'm like, ooh, it's done a calculation. And you know how I've said before about storing variable results? Well, it's done the exact same thing because the result was set as true. And now it's printed out here, true. And yeah, okay. Does anyone have any questions on that? Was it a little bit confusing or?
All good? All good.
Good. All right. Now I'll just quickly mention this. Now, you know what's cool is you can actually get multiple. Oh, sorry, we've got a question. So does it automatically convert the integer to string when printing? No.
Pretty much. You just gotta. It does the calculations first.
Well, yeah, it does the calculations first. Yeah.
Yeah.
Still kind of like an integer result. Now, did you know that you can get multiple texts outputted into one line? Now, by that, the way you can do that is remove the ln. So basically, if I did system.out.print, notice how it's not print line, hello world, and I do system.out.print wow, you'll notice at the bottom here, it says hello world wow. So basically, those two are now in one line or printed out in one line in the console, which is basically this thing here, which is actually a pretty cool technique that I thought I'd just quickly share.
It's useful like for 2 projects. It's weird.
It's
we used it twice. That's essentially it. It's really confusing.
I mean, it's a little bit weird, let's just say. But anyway, let's go on to something a little bit more trickier than statements. Variables. And as you can see, variable names is something that can be a very tricky thing to do sometimes, which we'll get into. But before we begin, we've got to understand what are variables. And in that case, a variable is just basically a reference to a memory location that basically stores data like letters, numbers, symbols in a program. And when you think of it in Java, you probably hear the term containers, because that's basically what they are. Variables are more containers, because what they do is they save and they store data values whilst the program is running. And that you'll see some examples in a minute. But before I continue, we have some important points here. Now, the value that is stored in a variable can be changed during execution. So let's say I have an integer variable that I set as 5. And later on, through some if condition or something like that, I change the value changes. Or I want to change the integer value to something a little bit different, like 19. Well, I can do that with variables. And that explains the point of it can be changed. The value can be changed. Now, all operations that are actually done on a variable, such as usual arithmetic operations, can actually affect the memory location where the data is being stored. And all Java variables don't necessarily have to be instantiated, but they must be declared before use. Now, what that means is you can declare a variable, like, for example, state its data type and the variable name, but you don't have to actually set a default value for that. So with understanding that a bit, let's know a bit of the syntax. So might have had a bit of a hint on that, but here we have the data type here with the syntax and the variable name. Now with variable names, I'll quickly mention this. Variable names use the common naming convention called camel casing. Now, camel casing is basically where you've got the first word, or just letters, lowercase letters, and then every word afterwards that is connected, the first letter of that word is a capital letter. And you'll see here, so we've got variable here, all right? That's the first word, it's all lowercase letters. And the second word, notice here, the first letter of that second word has a capital letter. That's essentially how camel casing works in this case. And that's the common naming convention for Java here. We don't use snake case. We don't use other naming conventions like Hungarian notation that you might have heard of before. But overall, this is the kind of naming convention that we use. And remember, semicolons must be placed at the end of every statement. And this is a good example of that when you're declaring variables.
Oh, do they prefer initiating? Yeah, it depends on the task. It really depends on the task. So, oh, sorry, I'm eating. First 5 weeks, they make you know the difference between. They want to hammer into the difference between instantiated variables and non-instantiated variables. So they make you prove to them that you know the difference by using a bunch of tasks that seem redundant because they are redundant.
Yeah,
that was the end of my sentence.
Well said, Jordan. And yes, so here's an example of a name as we've done before. So we have string data type, and I've just put sample my name. So it's a string variable, but it hasn't been instantiated yet. So what happens when I don't instantiate? And I want to display the value of a particular variable. Will it lead to an error when you don't instantiate? The answer to that is no. Java has a default value for every variable you declare depending on the data type. Now you can see the data table on the right here. So we've got for characters, it's usually just 0 or something like this, U0000, because with characters, you can store numbers from 0 on to a certain number or a single letter that's in single quotation marks. Now you've got string here, which is in null, which is not in quotation marks, I should point out, which might sound a little bit confusing, but when you don't have any kind of set string, it will basically be set to null because nothing has been set. Now for integer and long, kind of makes sense. You've got 0 here. And for booleans, it's basically set as false, right? Because there's nothing that's been set as true. So we assume it's that. Now, if you actually want to instantiate something, which is possible and usually very common, all we need to do is set the value. So like in the syntax here, we've got type variable name for declaring a variable. And just to instantiate, we just need to put equals and whatever value that is. So for example, we had a string, we basically put in quotation marks, insert text here. Or for numbers, like integers, we just put like value 19, for example, and so on. What question? Oh, this kind of answers my question. Okay, that's good. That's good. All right. So something that I really want to point out, because variable names can be very tricky, and people spend forever just deciding what variable name I'm going to pick and be precise on that. And they spend more time than actually spending time on actually writing the code, which is more important. So here's a few steps to help kind of like simplify that process. So the naming convention used, as I said before, is camel case, where the first letter of every word is a cap, apart from the first word itself, is a capital letter, unless you're just using one word where it's all just lowercase letters. Now, you should keep the variable names short and sweet while also making sense. So for example, if you have like, let's say a car class, and you have want to make variables related to that class or object in that sense. Now, you don't want to make something that's completely out, doesn't make sense. Like for example, person, like person's age or something. Like that probably doesn't make sense in some case. Anyway, variable names cannot be reserved keywords in Java. So for example, you can't set a variable name as int, because int is a reserved word. And also, variable names should begin with a letter. It should not begin with a number, and shouldn't really begin with a symbol either. It should begin with a letter.
Also advice, don't make them homophones, because like they'll make you describe almost every line of the code. So what is this and what is this? And before there was a case where I was comparing two booleans and I named it bool, B-O-L-L, no, B-O-O-L, and B-U-L-L. And it was great saying this bool is different from this bool, and bool isn't bool, but bool, blah, blah, blah. It was great. It was great. Next.
All right, and with that,
Data types, me. Okay.
that's time.
What's a data type? Guys, it got any clue? Probably not. Next slide. So data types are how Java puts these numbers or letters into memory, right? They have different sizes, but you just got to know how to use ints, because byte is small, short is a bit bigger, integer, perfect size. You got a large range of numbers. That's essentially all you need. You got the long, which is a bit too long. You got to put an L at the end of each number. It's a bit, it's like you use it, but only for first couple of weeks when they also want to hammer in what integers are. So what these data types are, what these variables are. It's confusing, but just know they're going to use int because they don't really care about storage size at the moment. Float and double, they're just numbers and decimal points. They use a complicated math system, which you will learn in like 1047. Is it 1047? Yeah, 1047. You'll learn about how floats and doubles are calculated. It's weird. Booleans are just the yes or no. It's on, off, 0 or 1. It's just true or false. Char are letters, numbers, other characters like exclamation mark. And string is a bunch of characters. They're not actually a data type, but like they're essentially treated like a data type. Refer to this table as much as you want later on. Trust me, you're gonna need it for the first couple of weeks. Next slide. So that's a lot of information. How we're gonna use it is I'm only gonna share screen for like 2 minutes max. Give me a second. Okay.
Stop sharing a sec. Okay. Off
Yeah.
you go.
Let's go. Beep, beep, beep. Okay, so let's say we have a variable loading. There you go. Oh my God. So code. Okay. That's wrong. That should be refactored. Give me a second. I need to refactor that because that is unprofessional. Beep. Rename code. Capital letter. That's upper camel case. Lower camel case is what we use for methods and stuff. PSVM. So we have this thing called short. Shorts can only get to 32K-ish numbers maximum. So the numbers can only go up to like 32K-ish. I don't remember the exact number, but it's there. So let's say we have a short called number, and we want it to reach 50K, which is outside the range of shorts. Well, 1, 2, 3. Okay. Here it says that it wanted a short to be in this variable, but it didn't get a short. It got an integer because the number is just too big. If it was only like 5K, it would be fine with it because it's within that range of 32 something, negative 32 something K to 32 something K. I don't remember the number. That's essentially it. All good. Guys get it? Sweet.
All right. Okay. Next slide. Okay. Now that we've gone briefly through data types, hopefully you understand the few kinds of data types that are available in Java. We're going to go through some operations. Now, I've said this a couple of times about operations, but let's think about it like this. What mathematical operations can I perform, and how do we actually write them up in Java? And that's kind of what we're going to go through in this section. So let's get this up. So we've got a few symbols here, the most common ones. So we've got addition, we've got subtraction, we've got the multiplication kind of using for the asterisk notation, which I assume most of you probably use for multiplying because you wouldn't use X. Division as well also makes sense with the / that we use. And for remainders, we use percentage symbol for finding, for example, 3 divided by 2, the remainder is 1. And these are the 5 main symbols that you would use very commonly when you're doing Java expressions, or simple Java expressions, I should say. Question in the chat, storage. Is there a reason why you would use short over using int? It would be storage reasons. So, for example, short only, if we go back here, short only stores the storage size for short is only about 2 bytes, but you notice here integer is about 4 bytes. So if you have a number, if you have like a variable number that's like, for example, 19, you'd probably use short. But for numbers that are larger than 32 grand, you probably need to use an integer.
Realistically, you won't actually need like to worry about storage. That's why I'm saying use integer for all your coding in 1051, because your computer can run it. You have enough space, honestly. Essentially,
yeah. But it's good to know about the storage size, especially later on. Right. So going back to this. Now, apart from those symbols, there are, of course, more mathematical expressions that you can try out and more symbols that are out there in Java. But these are kind of like the basic operands that we use quite often. So make sure you understand what they are and how they work in that context. Because I remember in 1051, you have to do a fair bit of mathematical operations. And if you do Python or C++, chances are you'll have to be doing a fair bit of these equations as well. So here's a quick example, okay? So I've got 2 variables here. They're both integer ones. So I've got x set as 1, y set as 2. And I've got 2 other variables that basically perform mathematical calculations, such as x plus y and x times y. Now, I have a question for you, all of you here. When I multiply x times y and store it in A, does that affect z here? Is that a yes or a no?
no.
No, that's correct.
Okay, no.
It is not. It has no effect. The result of Z has no effect into A. So make sure you understand that. Now, with Booleans, we've got y modulus 2 equals 0. We've got this here. Now, is this going to end up as true? Or is that going to end up as false? So we've got y set as 2. We've got this percentage here. Does that equal true or does that equal false?
Oh, equals means, hey, is this equal to this? Question mark?
Yeah.
Oh yeah, that's the difference between equals and equals. Equals is like x is equal to 1. That's a statement.
Yeah.
But to like y equals 2 is asking, hey, is y equal to 2? It will end up being a Boolean.
Yeah, so basically this double equals is more like a comparison, like checking if y modulus 2, if you calculate that, whether that is actually equivalent to 0. And that just, yeah, it's just a Boolean check there. It's not the same as an equals. Yeah.
Oh, that's true. Yeah, you're right. Let's go, Terry. You're answering the questions. Perfect.
Yes, it is true. You are correct. It is
Because
true.
when y is divided by 2, is there any remainder? No. That no remainder is equal to 0.
Yep. Indeed. And that leads to our first exercise time. So
Oh, shit, yeah.
let me stop sharing my screen.
Breakout
Let
rooms.
me get out of this. So today we've got a few exercises that I'm going to share with you guys, and we're going to end up in breakout rooms. So we've got some basic statements here and some operation questions. We'd like you to have a go at some of these. If you need help, just let us know. We're going to go into breakout rooms. So
4, 5. I don't know how many.
we've got, I'm going to stop sharing my screen a second, and I'll post the questions in the chat. If I can. Try again.
I'm gonna be back.
Won't let me. Okay, so the first questions I'm going to put on the screen. All right. So first questions are there. Those are the basic ones, and here's some more incoming. And these ones. So now what we're going to do is we're going to go into breakout rooms. So just give me a moment while I arrange them. We'll make about 4 breakout rooms and create. And we'll go open all rooms. Okay. Might have to move them.
Yo, I didn't get a room, dude.
Oh, we get you into one. I'll get you into room 3. All right.
Cool.
Hi, Dill.
Hello.
Hello.
Okay.
All good. Just gonna go into breakout rooms and go over some of the questions.
Okay.
I'll take you into room 1.
You give me go host.
Oh yeah, of course. Oh, make co-host. Yep. Okay.
Thank you.
All right. I'll go into room 1. Hope you're all doing okay. Do any of you have any questions on any of the exercises? Or anything like that? Do you guys want me to go through kind of like one example of the questions? Oh, let me pull this through. And we're back. Hello, everybody. How did you guys find the exercises so far? Were they all right? Were they a little bit tricky? I think one of them was a little bit tricky.
Because
Overall,
it's hard to ask that question after all.
A little bit straightforward. But without any further ado, we're going to get started with conditional statements. Now, this is a little bit more trickier stuff. Hopefully, when we explain it, it will hopefully be a little bit easier for you after this. So, conditional statements. You can think of it more like, okay, I've got a set of options, right? And, you know, I take certain actions based on what option I want to take. Or it's like asking a question, providing options, and implementing actions based on certain options that you pick. Okay, it's kind of like that. And to kind of explain it in a bit more detail, we'll show you kind of how the syntax works and stuff like that. So let's say, for example, I have 2 numbers. One's called X and it's 43,000 odd, and another variable called Y, which is like 320 odd thousand. So if let's say I wanted to check if the number stored in X is the same as the number stored in Y. And if that's the case, we'll actually do something. We'll do a particular action. And if they're not, we will do another particular action. We'll do something a little bit different. So basically, what I'm trying to say here is, it depends on. So let's say I have a condition, right? If this is true, I'll do something, and if not, I'll do something that's a little bit different. That's kind of how if conditions work, and if else is a great example of that. And overall, it's relatively simple, I would say. Now, there are some other kind of if else that are a bit more complex. For example, you might have multiple options. So for example, if X equals Y, we do a thing. Else, if X is greater than Y, then we'll do another thing. And else, if X is less than Y, we'll do something a little bit more different to the previous things that we could have done. And that's basically it. It's actually quite relatively straightforward, and it's a very useful thing in many programming languages. And
Loops, that's me.
Yes, loops.
So loops, they do this code a bunch of times until you tell it to stop. Well, give it a reason to stop. Next slide. There are different types of loops. First and most obvious being the next slide. Come on, next slide. There you go. The for loop.
There we go.
There, for loops, finally. Bloody, it took forever. Okay. For loops looks complicated. Just know the middle bit is the part that has to be true. It's the Boolean. You know how like if else, it does this if the Boolean is true. The middle part is what needs to be true. So the I is less than 10. Ignore the first part. Just focus on the second and third part. So the second part is I is less than 10. That happens. It checks it if to continue the loop, to continue doing the code. Once that's false, it goes on to the rest of the code. The I++ is the thing that gets run at the end of the loop. What is I++? Well, it is Jamie's turn. What's the next one?
Yes, that goes over the next point of going back to operations. How can we efficiently increment and decrement in a loop? Because it's a very useful tool for loops, and especially in the context of while loops. Without these, while loops will basically continue forever. And as a result, you'll probably have more errors, some crashes, and it just will run non-stop. You might have some storage issues after that, let's just say. Anyway, and here's an example of such, of a while loop being used. Int I equals 0 here, right? We've got our variable. Now, while I is less than 5, we'll print variable I is equal to, like that. And notice at the bottom, we've got the incremental. Now, what happens if this is missing? What happens if let's say I just remove it and I just let that keep running? What will happen? Will this condition always be satisfied?
No, because you're always increasing I by 1 at the end of the code.
Yeah. So essentially, basically what Jordan is saying is without this, this will just keep running over and over and over, and you're just going to have so many errors that will be runtime errors. Now, in Java, you can, now what is I++? You can actually, this is basically incrementing by 1. So let's say, for example, we start with 0 and we go through the first bit, the first part of the loop. The I++ means we'll increment I, it's like I equals I plus 1. So I will change from 0 all the way to 1. And that process will keep continuing, 1 to 2, 2 to 3, 3 to 4, 4 to 5. And it's the same process with decrementing as well. You can decrement an integer by 1 by using I minus minus instead. So let's say, for example, we start with 10 and we want to check, well, I is greater than 5. Instead of using I++, we would use I minus minus here. Now, another thing here is instead of, if that was a little bit confusing to you, you can also use I equals I plus 1. Or if you want to say like, you know, this is I will be added by 5 every iteration or by 2, you can do I equals I plus 5 or I equals I plus 2. Or even something like this, which is called augmentation. Now this probably makes more sense. I would focus on understanding this. And if you feel more confident in that, try this out. And now we're going to go through while loops. Hopefully, you understand how incremental has a very important part in for loops and in while loops. Take it away.
I'm surprised that like while loops was used as an example in the previous slide. So okay, while loops, they're like if statements on steroids. Essentially, while this is true, if this is true, do this code. Just keep on doing it until that is false. It's like an if statement, but you have to keep on doing it and doing it and doing it. That's essentially it. There's also a do while loop where you have to do it once at the very least, and then you do it again while this is true. That's just like, it's pretty similar.
It's a very similar thing, but it's like you put the condition more at the bottom instead of like at the top. There are some small differences, But in terms of do while and while, they're very similar in terms of the structure. And you still need the incremental, you still need the code. Yes, please, please, please. One does not simply forget to increment the counter in a
Oh my
while
God, that's
loop.
an old ass meme, man. Okay, essentially,
I
just
know,
always
okay.
increment.
Listen, man.
Always increment. Oh, it's an exercise time. Let's go.
All right, it is exercise time. We've got some exercises to show you for if, else, and while and for loops, which will give you about 15 minutes to have a go at. So what time is it now? It is about 10 past.
11.
So okay. All right, cool. So I'll stop sharing my screen and I'm going to give you all the questions. Go check it. I will give them to you in chat. So our first ones are going to pop up on your screen in just a moment. So here is all the if conditions, if else. The next ones I'm about to put up are for loops. So that's for loop. And the last one's write a program that counts the number of iterations. And yeah, that's it. All right, there's a lot of them here, so we might go a little bit longer, maybe about 15-20 minutes. We're going to go back into breakout rooms again. So open 4 rooms. And feel free to go and join them, and tutors will come and assist you with that. Cool. Okay, there we go.
Record. Now it's recording. Okay. So you got methods and objects. I thought there's also classes. Anyway, I'll touch
kind
on
of links
classes.
up.
Anyway, methods and objects. Okay, methods and objects are things you'll learn at the very start of Java. Well, also classes. That are a bit confusing, and you really don't have to know the details of how each work until the very end, and they'll teach you in detail what it is. But just know that there are classes. Classes are things like, for example, in this example, there's dogs. Dogs have variables like breed, size, age, colors. Now, objects of those classes, so variants of that type of thing, are like Neapolitan Mastiffs, Maltese, and Chow Chows. They're different types of the class dog with different variables or different, you know how variables like in container, they have different fillings for that container because they have different breeds, different sizes, different ages, different colors. Anyway, they also have methods. Methods are things that you can do. It's a bit complicated. Next slide. I would have had something here about methods. Okay, they're methods. Okay, so methods are a bit confusing. They just do a thing. They can have an input, they can have an output. Sometimes they don't. Sometimes they mess with whatever the input is. Sometimes they just mess with what variable that object has. The structure of a method gives all that information. So there's like public, which is, the first word is either public or private, which means it can be interacted with by the code driver or not by the code driver, depending if it's public or private. Void, integer, the next word will be what is the output. Could be integer, could be string, could be a short, one of those. It could also be void, which means has nothing, no output.
Basically,
then the next part is the name. Oh, what is this part? Oh, the void method. Okay, never mind. That will be explained soon. Then you have the void, so the name of the method, which will be used by the class from previous. It's really confusing. Just know that methods do something and they'll explain it to you within more detail later on.
essentially there are two kind of methods, basically, just to clarify. So there's one that basically returns something, like not necessarily you can provide some like something like int input, like some kind of what's the word? Some values into the method that will basically make an impact to the code or not. But essentially you've got two kind of methods. One that basically returns something. Now the static, basically what I've just put here is you can remove the static keywords, but it means you cannot call it in the main method. And when you go through static and non-static variables in FitChamp 51, you'll hopefully understand it a little bit better, like why is that the case? Now for void, that does not return anything, as Jordan pointed out. And this is an example of one that we did. So a lot of it is more like we call methods, or for something like we just display some output, like some of the exercises we've been showing to you. Now, as we said, no return statement, but what happens if we include one here? Well, we basically lead to an error because we have a void here. We can't really return anything. Yeah, and then we'll go to the next bit. Off you go.
Oh, objects. Okay, I already told you about objects. They're a type of they're a part of the class, they're a version of the class. They have their own custom data types. So like how they're strings and strings, integers, and all that sort of stuff. The class is a blueprint, and the object is the object that comes from that blueprint. I think I explained it within good enough detail in the previous couple of slides, though. So it's all good.
Yep. Awesome. So some final tips and tricks. Now you might have noticed in some of the examples I did, there's a couple of slash lines here. Now these mean comments here, and there's kind of two different kinds of comments. So you've got these, which basically is a single line comment, and this here is a multi-line comment, which I can put through multiple lines. For example, I can put insert in one line, multi-line in the next line, comment in the next. You get the gist of it. Now, something that is important is learn to talk to yourself, right? Because why is that? It kind of helps you understand the logic of the problem, as well as kind of dealing with coding errors. It's kind of like a debugger. Like you think about it, okay, where did I go wrong? So I did that and I did that. Oh, that's where it is. So it's good to actually talk to yourself and think about, okay, how can I solve it? Help you deal with bugs, errors, and so on. And last but not least is the public static void main. I made sure that was included in here because this is very important. Now you might have seen in some of the examples, or to execute any program, you basically need this. You can call methods using public static void main. You can display stuff through that. It essentially just helps execute any kind of Java program that you have with different classes, objects, methods, and so on. So overall, it is a very handy tool that you'll have. And finally, there are a few things that I need to just want to remind. Always make sure that after every single statement, that is not an if else, a loop, or method class has a semicolon at the end. For if else loops and classes, you'll tend to generally use those curly braces that you might have seen in examples and in the syntax. Now make sure you choose the right data type for your variable. So for some, like double and integer variable data types, they can actually be converted with casting, which you'll probably learn later on. But not all can. For example, like strings and like booleans, if you've done one of the exercises we did. Now, it's as with the naming conventions, it's best recommended to use camel case for variable names. Don't use different types of naming conventions like snake case or Hungarian notation. Be consistent with it. And finally, learning the theory can be useful, like learning the PowerPoint slides. Yes, that can be useful. But to fully understand the concept, and that's just common sense, you just have to try it out in practice. Practice, practice, practice. Make sure you try your best with all the labs tasks that you do, no matter what you're doing, whether it be computer networks, whether it be doing programming and so on. Good to practice. And if you want to read further, you can go here with W3 Schools. Code Academy has a few online good resources, and there's even some from the developers of Java itself. They have and their site is really good for learning the kind of keywords that are in the Java programming language and so on. So I would suggest checking these out. And that's it. Thank you very much for attending our presentation. And we hope it was somewhat helpful to starting Java. And yeah, do you want to say a few words, Jordan?
Oh yeah, there's some traditions with coders. So coders have this weird tradition where first you get a rubber duck and you talk to them for the debugging. There's also another one where you cross-dress to get better at coding. I'm not kidding. It's called coding socks. Get coding socks. Or you can be like me and like full-on cross-dress. Like I have a made out and everything. There's a reason why like I am the trap of our server.
Yeah, okay.
Getting dudes DMing me thinking, hey girl, and all that shit. Fucking hilarious.
Yeah, but overall, I hope you enjoyed it. I know it's a little bit awkward sometimes with because I'm quite new to actually presenting stuff, but I hope it was helpful, it was informative, and it made sense. Now, if you want to view all the if you want to view the presentations and stuff like that, we will be uploading them after this presentation goes out. Yeah, you'll be able to get all the resources and information you need. I will probably send them on Discord. Oh yeah, any questions? Any questions? If you have any questions, feel free to hit me up right now, or you can DM me. I'm perfectly fine with that. Otherwise, oh, got a question?
Sorry, James. No, you finish. I did have a question. If no one else does.
I'll stop recording.